Today we're going to be reviewing the concepts that go with density. So to start, we're going to be looking at something similar to this, where more dense objects sink to the bottom. That'd be like this corn syrup here, or the metal bolt that's sitting next to it, or the very low density things that float to the top, like lamp oil or even a ping pong ball. So to give you guys an understanding of why we test things in science in order to determine things before just assuming them, right? Ping pong ball, it floats. A glass marble, it sinks, right? A pebble, it sinks. A black rock also sinks. And then a piece of wood, it floats. Another rock, it floats, right? So we always want to test things because sometimes, like if you're given a rock, you may think, oh yeah, it's a rock, it's definitely going to sink. But in this case, this rock floated. So we like to test things. And we also like to come up with numbers for things so then we can compare them to each other other than just saying, yeah, they both sink, so they must be the same density. Because they're probably not unless they're made of the same material. So let's get into this. What causes things to either sink or float? This is going to all have to do with density. So density, again, has to do with an object's mass divided by an object's volume, right? So that little slash means divided by, or we could set it up like this, where the mass is divided by the volume. So what is mass? Mass, for this class, we're just going to say mass and weight are pretty much the same things. In reality, that's not absolutely true, because your mass is always the same whether you're on Earth or you're on the moon or you're in outer space, because you're made of the same stuff no matter where you are. But weight is more dynamic based on gravity. But like I said, for this class we can think mass is the same thing as weight. So heavy things have a lot of mass, light things don't have a lot of mass. Volume is a little more complicated, because when we talk about volume in the regular world, we usually say, hey, turn up the volume, make it a little louder, right? But in science, volume really is a description of the size of an object, right? So the volume of this rock is greater than the volume of this ball. And all I'm saying there is that the rock is bigger than the ball. It's just that I'm using the proper vocabulary that goes along with it. So, what is density? Again, density is a relationship between an object's mass and its volume. And that is what's going to determine whether it sinks or floats. Remember, if something weighs a lot, like a big ship, it still floats even though it weighs a lot. And if something as small as a piece of sand doesn't really weigh much, it still sinks because of what it's made of, its material. That determines its density. All right. So what does 1 milliliter of water look like? So milliliter isn't a description like grams or pounds, which would be weight. Milliliter is a description of size. So there's a lot of milliliters of water here. And it turns out that 1 milliliter of water kind of looks like the amount of water that you can fit on the surface of a penny. So this is a penny here, and it forms this little dome, and that's about what 1 milliliter of water looks like. So a milliliter is a small amount of volume, or a small size. So there's really some things that you have to know going into density. First is that milliliters describes the size of an object. All right? So the more milliliters something has, the larger the object is. I have more milliliters of body than this has milliliters of water, right? And a balloon the size of my body would have the same milliliters of volume as my body, or the same size as my body, okay? And also, if an object has twice the milliliters of another object, that means it's twice the size of the object. An example of this would be marbles. An 8 milliliter marble is twice the size of a 4 milliliter marble. Okay? So hopefully that makes some sense. Some more important points. Mass is found by weighing or using a balance, and we usually determine that in the unit of grams. Volume is the size of something, and that's found by either measuring the length, width, and height of an object. So like, that's really only possible with rectangular and cubic shaped objects. So like I could find the length, the width, and the height of this, multiply them all together, and that'd give you the volume of this. Or you can put the object into water and measure how much water it displaces, or how much room it takes up. It's gotta move the water somewhere, all right? So, this is gonna be a question that's embedded into the video, so you'll see this. We all know ice floats in water, right? You get a glass of water, you fill it up with ice, the ice floats in the water. So, can I make a piece of ice so large and so heavy that it will sink in water? Okay? Try and answer that. Now, another thinking exercise. We all know that rocks, well, in most cases, not this rock, but let's say this rock. Rocks sink in water. So can I make this piece of rock so small, so break off a piece of the rock, make it so small that it will float in water? The main idea behind this is if an object is made of a certain material, that material determines its density. So ice is made of frozen water. No matter how much ice you have, it's still frozen water, so its density will remain the same. So if we have something like this, a giant iceberg, if you notice, part of it sticks out of the water and part of it sinks into the water, but we still call this floating. This is still floating because it hasn't sunk to the bottom. So no matter how big a piece of ice is, like this iceberg, it is less dense than water. And no matter how small of a piece of sand I make, if you go to the bottom of the middle of the ocean, there's such small pieces of sand. We actually call them silt and clay. They're such small pieces, but they're still made of the same stuff as this, which is why they still sink to the bottom. It's not like we have a bunch of little rocks floating around in the ocean. They all end up sinking to the bottom. All right? So don't get caught up in the idea that small things float and big things sink. That's not true. It's all about density. So let's imagine, and this is the final part. Let's imagine this is a rock, right? So this is a rock, and I put the rock into water and it sinks. See, there it goes. It sank to the bottom. Now, the mass of this is 48 grams. And the volume or the size of it is 12 milliliters. So that means if I put this under the water, right, the water level rises 12 milliliters, which means that this takes up 12 milliliters of space. What happens when I break this in half? So if I break this in half, I'm going to rip it in half. Now that it's broken in half, will these sink or float? Let's test it. I put them in. Oop, it sinks and it sinks. Why is this? Because they are made of the same material. It's the material that determines the density, not the size and not the mass of it, the material. We just use the object's mass and we use the object's size to determine its density. So when this was one piece together, its density was 48 grams divided by 12 milliliters, mass divided by volume. And that'll give us, if you plug it into a calculator, that'll give us 4 grams per milliliter. The density of water is a density of 1, and 4 is greater than 1. So this density is greater than the density of water, so it sinks in water. Now, when I cut the object in half, right, it's in half, that means its mass was cut in half, right? So it weighs half of the amount as when it was one piece. But not only is the mass cut in half, but the size of it is also cut in half. So that means the volume is half of what it was before. So the original mass of it all as one piece, 48 grams. The original volume, all as one piece, 12 milliliters. Now that it's in half, we're going to get half the mass. Half the mass, which is what this is 24 grams. Half the volume, or half of 12, is going to be 6 milliliters of volume. Now, let's use the new mass and the new volume to determine this object's density. So when it was together, the object's density was 4 grams per milliliters. Now that it's in half, the mass is cut in half, but also the volume is cut in half. So if we plug this into our calculator, 24 grams divided by 6 milliliters, which is mass divided by volume, we're going to end up with 24 divided by 6, 4 grams per milliliter. So my point is, it doesn't matter how small of a piece you take off of this. It will continue to sink in water because the material is not any different. And the material is what causes, or what gives it, the object, its density. Here's a really small piece, and I drop it in the water, and it sinks as well. It doesn't matter how small you make it. If it sinks, it sinks. If it floats, it floats. All right? So that's the main idea behind this lesson. Cutting or breaking an object into pieces does not change its density because its density is caused by whatever the material is made of. All right? Hopefully that makes sense. Enjoy.